Anthropic's Opus 4.7 is posting higher benchmark scores, yet developers plugging it into existing pipelines are finding that their applications fracture and stall. On paper, the integration is a straight swap. Anthropic positioned 4.7 as a drop-in replacement for Opus 4.6, maintaining exact pricing parity and the same 1 million token context window. The simplicity of this API transition contrasts with the reality of the model's new behavior, which changes how the system processes instructions and maintains output reliability. 3 specific architectural shifts are driving this friction: a reversal in tokenizer efficiency, the removal of loose instruction parsing, and the introduction of variable compute scaling. Adopting Opus 4.7 moves the developer's role from simple implementation to active pipeline reengineering. To understand these application-level breaks, we have to start at the absolute lowest level of the architecture: how the model perceives raw text. Historically, engineers assumed that as models upgrade, their tokenizers become more efficient at grouping characters together. But Opus 4.7 inverts this historical assumption. This shift in text perception ripples upward, affecting every metric from basic API costs to advanced reasoning tasks. The Opus 4.7 tokenizer update fragments text into a higher density of smaller individual tokens. This side-by-side comparison shows the shift. On the left, a legacy tokenizer groups standard Python indentations into solid blocks. On the right, the Opus 4.7 tokenizer shatters that same code into a much higher number of tiny, distinct fragments. Because the text is divided more granularly, the total token count for the exact same input payload ticks significantly higher than it did in previous versions. This fragmentation directly inflates the unit cost for processing specific strings of text. Anthropic kept the price per token identical to version 4.6, but because the model uses more tokens to read the same data, the total cost per task has increased. Developers must now recalculate their context window budgets and prompt length limits to account for 4.7's denser processing layer. Beyond the math of tokenization, the logic of prompt execution has also changed. Older models often provided a loose interpretation safety net, automatically bridging the logical gaps in poorly structured developer prompts. This flowchart illustrates the parsing logic. In Opus 4.6, a prompt like verify API key routes through a fuzzy match gate to reach a successful execution. Opus 4.7 routes that same prompt into a rigid, literal gate. Without explicitly stated parameters, the path hits a roadblock and execution halts. If a prompt for API key verification misses a specific step, 4.7 will refuse to infer the missing context, resulting in a failed task or an unexpected error. Prompt engineering for 4.7 requires deterministic, explicit logic rather than conversational alignment. The third architectural shift gives developers granular control over inference compute scaling. The new extra high effort parameter sits between standard low latency responses and maximum reasoning depth. At the extreme end of this spectrum is a new coding command called ultra review. An ultra review invocation can take up to 10 minutes to complete and cost between $5 and $20 per run. This vertical stack shows why. The primary ultra review node splits into 4 parallel subagents that actively scan the code for vulnerabilities. These parallel agents hunt for edge cases that a standard single-pass inference model would likely miss. The subagents feed their data into an adversarial verifier, which filters out false positives to produce a ranked list of confirmed bugs. To support these long-running tasks, 4.7 uses improved memory utilization to recall complex notes across different work sessions. Inference has evolved into a configurable loop where developers balance dollar cost against reasoning depth. To see where Opus 4.7 sits in the wider market, we have to look at how it compares to the current state of the art. Although 4.7 is the flagship public release, Anthropic is currently withholding its true frontier model, known as Mythos. This is part of Project Glasswing, an initiative to gate model capabilities based on safety assessments. This comparison table shows 4.7 trailing in specific categories. GPD 5.4 leads agentic search, and Gemini 3.1 tops multilingual Q&A. In cybersecurity, 4.7 shows a slight regression, dropping from 73.8 to 73.1%. Anthropic explains this as a deliberate effort to reduce the model's ability to generate automated vulnerabilities for the general public. These shifts suggest that frontier models are being increasingly engineered to enforce safety constraints, even when those constraints impact raw performance scores. Opus 4.7 provides a significant boost in capability, but it demands stricter operational discipline from the developer. Legacy prompt architectures must be rewritten to satisfy the model's requirement for literal deterministic execution. Developers should leverage multi-agent compute scaling when accuracy is prioritized over latency. Modern frontier models function as curated deployment profiles requiring active management.